today is about, oops, polymorphism, which is basically just kind of a fancy, one of these fancy words. It's polysyllabic, and it sounds fancy. But basically, it's that the basic idea, it kind of gets back to uh, this idea of having this a single interface to entities of different types. Again, this is from Wikipedia, um, or the use of a single symbol to represent multiple different types. But in practice, what it means is that the same code can execute differently depending on the specific type of object, and that is without the switch statement. In other words, and what allows this in an object-oriented language with typing is the fact that when you have a class and subclasses, if you define the type to be the superclass, then any instance of the subclass, regardless of what type it is, can be used in the same place. The constraint being that you can only do things to it without casting, that are defined in the superclass. And we kind of saw a little bit of that with the pets, in that the pet was the superclass. Then we had a specific one of a cat and a dog, and we could have a hippo and a canary and a hummingbird and a tarantula, and they would all could be a subclass of pet, and you could do anything to a pet, to any of those instances, that you can to a pet if it's defined to be a pet as the type. On the other hand, if you could define an instance specifically of that subclass, the disadvantage being that you can't, for an object of that type, you can't do anything that's specific to the other ones. So, here. Okay, so the book has an interesting example in this, and it's worth it to look at how the book does it. I'm going to do a similar example that involving instruments, just because I think that it's a little more concrete. Because to my mind, this is, well, it's again, it's useful to go through the book, how the book does this example, because they take it and they kind of extend it fairly far. And again, all of that is worthwhile. I have a slightly different take on that, which I'll be showing you in a bit, which covers kind of the same ground, but in a slightly different way. And just because that's having played music all my life, I kind of I'm a little bit oriented toward a slightly different approach. But anyway, see right here, this again, this is just the basic example. And the idea is that there's this, so they define a note, an enum, which again, an enum you can think of as the same as a class, in that you can define, notice that the arguments here for the play method all have a note as its signature. And again, a note is an enum. And again, and even though it has a different name, because it's, you can do things with a class that you can't do with an enum, just in general. So with an enum, remember, that in this particular case, if you define an enum to have these values, then an enum can only take these three values, period. And under the hood, what it also gives you is it actually associates an integer with each of these. Again, it's not, you can't put it in place of an integer, but you can treat it kind of like an integer, and you can treat this entire group of, of note enums as an array. In fact, you can actually get the array from that. When we do a deeper dive into enums, we'll see some of the things that can go on there. But its use is mostly for abstraction in a way. In other words, in the code, if I use, say, a middle C as in the code, then ideally, if it's clear what it is that I'm representing. If I use the integer 0, then it's not clear what I'm representing. So the reason for these enums is that it makes the code a little bit more clear. In a strongly typed language like Java, it also has the benefit of creating a strong type. In other words, in this world here, and in the one that I'll show you in a little bit, these instruments can only play these three notes. That is, these three values are the only ones that can be put wherever there's a note. Okay, so that's the enum angle. But the polymorphism angle has to do with the fact that an instrument class defines this method called play with an argument that's a note, this enum. And so anything that's a subclass of that, such as a string, that's not a Java string, that's like a stringed instrument, like a violin or cello or viola. Brass or wind, again, and the thing to understand too is that as far as Java is concerned, these are just names. These are just names. So it's like that saying, which is attributed to Abraham Lincoln about, I guess he was asked, if you call a tail a leg, how many legs does a dog have? And the answer is it still just has 4, because calling a tail a leg doesn't make it one. And likewise, these are just names. And ideally, the names are, you define the names in such a way that it's if you're reading it, then it's a good representation of what it is you're trying to do. So, for example, the single card, that's could have been called card. Single card is very descriptive. It emphasizes the fact that an instance of a single card represents one single card. A card deck was representing a deck of cards, and a poker deck was representing a deck of cards that you can deal out poker hands with. So the names are suggestive, and good names are very suggestive and indicative of what it is that the code is doing, but that doesn't necessarily make it so. Okay, so the idea here is that when you have this inheritance here, you have choices. So if I'm putting together an ensemble, and presumably there would be a bunch of other stuff, and but again, this is just as an example of this polymorphism idea, that when I invoke play on something that's defined to be an instrument, then it will invoke the play for that particular thing. So again, this is important to understand, because it can be a little confusing. if I declare a variable to be an instrument, then I can put in any one of these three objects, an object of type string, an object of type brass, or an object of type wind. That can go into a variable of type instrument. And furthermore, when I invoke play on it and pass it a note, one of these three values, since the play method is defined in each of the subclasses here, so the code is, you can look to the book for what the actual code is, but that isn't the important thing here. The important thing is that because the diagram says that string has a play note method, that means that string is going to override this play method, and string will have its own, and likewise brass and wind. Why? Because presumably, I mean, if you're familiar with these instruments, I mean, if you hear a cello play a middle C note, and if you hear a trombone play a C note, and if you hear a clarinet play a C note, then they're all the C note, but they're certainly going to sound different. That's kind of the idea. So from a programming standpoint, there's something which in the program distinguishes each of these different types, so that when they play, something else happens. I mean, if we had time, we could possibly connect this to some type of MIDI device, so that when the program ran and say a violin played one of these notes, you would actually hear it as if it were like a violin, or if it was like a tuba playing a given note, it would sound like that, etc. Obviously, that's, well, maybe not obviously, but I think it's obvious that that's a bridge too far in terms of what we have time for here. But that would make it very, very concrete. Okay, so this is the book example. Again, that's one way of looking at it. And the example that I prefer is as actually a little bit more like this. So the idea is I have some different notes here. Again, in the full-blown thing, I mean, in the orchestra, there are only a certain number of notes that can be played. It's a fairly long list, but there's nothing to prevent the note enum from having every single one of those. So, but again, for a class example, I'm just going to stick to these three, and you'll see why, hopefully, at some point. But for this example, what I wanted to define a second enum. This is an enum as well, called family, because in the orchestra there are four different families of instruments. And so the idea is that in the instrument class, it would have an instance variable of type family that would say what family it's from. And I'm also defining an instance variable called a tuning note. So, and where does that come from? The fact that whenever one of these instruments tunes, because you try to stay in tune, because the different instruments are in different keys, as it were, they each tune to a different pitch. So just as an example, the strings, violin, cello, viola, double bass, all tuned to an what's called an A440. A trumpet, now there are different flavors of trumpets, but the typical trumpet and a cornet will typically tune to a B flat, as does most of the other brass instruments, except for the French horn. So a French horn actually tunes to a low F. Now, if you notice in this example, again, each of the subclasses have this play method, the same as in the book example, but there's an additional one that's only defined in the instrument class called tune. And I wanted to me, that kind of illustrates the polymorphism idea a little bit more clearly. So, okay, what in dissecting this UML diagram, okay, the enum ones are pretty clear. With, darn it. The enums are pretty clear. But okay, now what just to understand what's going on here, in the very top is the name of the class or enum or interface, as we'll get to later in the course. The next section these are going to be the instance variables defined in the next section, and they are in the full UML specification. There are additional little pluses and minuses and other little indicators of what's going on. Just this kind of simplified notation is a little bit clearer to me. So these are instance variables. So this says that the instrument will have these instance variables. And so to meet the specification, if you're implementing the instrument class, it must have these instance variables. And then the bottom place is consists of the methods. So this defines now the method that matches the name is, of course, the constructor. So what this says is that the constructor for every constructor for an instrument has to tell you what family it's from. And it also specifies two methods, one called tune with no arguments, and another called play with an argument of note. Now, the other thing to understand here is that the signature is sometimes it's given in, let's see, in the previous one. Yeah, so here the signature was given with the variable name. And sometimes you'll see that, and sometimes it's just the signature. So here I've done it with just the signature. It's not that one is right and one is wrong. It's that the reason I usually leave it out is that the name of this is completely arbitrary and not part of the specification. So what these diagrams are, this is the specification for these classes. And so leaving it out, this says that you can define play and then call the argument whatever you want. So when you're defining, you can't just directly type public void play and then say note. You have to give the note a variable name. You have to give the argument a variable name. And again, I leave that out because that's really not part of the specification. Whatever you call it is fine, as you know, as long as it's fairly reasonable. Likewise, when I'm for the constructor, as we'll see, the family needs to have the name of the argument. But that's really not part of the design. This is part of the design. In other words, if I'm implementing these classes, as I will in a moment, then this is my design document. This is where this is the design for the structure of it. Now, what it leaves off are the public and the private. So notice these are instance variables, and so they are private. They must be private. And you know that is the one mortal sin, is to have a non-private instance variable. That's a mortal sin. Likewise, these methods are public. This is part of the public interface. Now, there may be some private things as well. It's absolutely possible to have private methods. We mostly will not encounter that here. But again, if it's in the UML diagram, then it's public. If it's the method, it's private if it's an instance variable. And we've also seen in the last assignment, we saw an example where there was a static one that was defined as well, and that was defined up here. And a static one is by default, it's private. If it's a final one, then it can be public. So, but that's sort of something. Okay, so any implementation has to match what's going on here. Okay, so all right, let's sort of keep those, and now we're going to implement that. So and hopefully, let's see. Okay, I wanted to sort of where are we here? Okay, there. All right, so I'm going to put all this in again another sub package. You notice that we're kind of going a little crazy with the packages here. It's probably better to start with more packages than you need, and then kind of consolidate them as things come up. Okay, so the first thing is, wait, I'm going to share the whole. Let me share the whole thing. Okay, can you see that?
Yes, sir.
Yes, sir.
All right. Okay. So let's start with the with an enum. So remember, there was a family, which is the family of strings enum, or the family. So there were strings. There was brass. There was woodwind. And even though we're not going to use it, they're just for percussion. These are the four families in an orchestra. Now, I mean, if we're talking about a band, then we're going to have there are going to be some other ones. You might want to divide it up differently to things like the rhythm section and the horn section, stuff like that. Again, how you organize it depends on what it is you're trying to do. And then the second enum was, where to go? There it is. Was our note. Again, for a full-blown thing, at an A440, we had a B flat, and we had a low F. And now, just you may have noticed this, and I may have said it, but the convention for naming the enums, and it's not quite as strict as some of the other ones, but the convention is that it's all caps with underscores separating things. Whereas the convention for classes is camel case beginning with an uppercase. The convention for instance variables and instance methods is camel case beginning with a lowercase. Those are the Java conventions. They're purely conventions. If they can be violated, and Java won't complain. But if you do, what it does is it kind of waves a red flag and says, Java isn't really my main language. I mean, it would be like, if you're speaking a foreign language, there are certain idioms that are used. So you can say something which is grammatically correct, but doesn't really make sense in terms of how it's used. Okay, so we're going to define a class called instrument. And now, okay, and so what's when you're defining a class, that one of the nice things about these UML diagrams is that they give me guidance. Instead of just opening up a blank sheet, a blank editor and starting to type, you sort of design first. You make a plan. This is like a plan. It's not sort of the whole thing, but it's all the structure. And so it gives you guidance about how to start doing something. So, and what I suggest is begin with your instance variables, then your constructor, and then your instance methods. And so for the instrument, okay, we have an instance variable of type family called family. And an instance of type note called the tuning note. Again, so each instance of an instrument is going to have one of these things. Again, what okay, so now here's the thing is that and for this is kind of optional. One of the annoying things about Python, well, it's both annoying and good, is that Python insists that you always use self for everything. And in many contexts, that's okay, but in some, it just makes things just totally crazy. Okay. So oh yeah, okay. So now the next thing is that what you want is you will typically, it's not specified here, but we often will at least have getter methods. So even though it's not in the design, I'm going to define getter methods for all of these. Now, notice that I've set the tuning note to be null here. So that really kind of suggests that we either need a setter or we need to add that to the constructor. So what I will do is I will add that to the constructor. I'm sorry, I'll add a setter to that. Okay, so what I've done is I've said, well, see if I just have an instrument, I don't know what its tuning note is until I find out what the heck it is. Now, there are ways, there are actually ways to sort of fix that, but here we are. Okay, so the other part of the specification is we have this method called tune. And sometimes it's helpful to just write just kind of write the skeleton of the method. Okay, so now for tune, again, because this is a class example, I'm going to do something which is which is in a real program is not a recommended thing, but I'm going to put a print line in just because I'm going, it's a class example. Okay, so, and what I'm going to do here is oops. Okay, what did I do here? Well, it turns out that every every object knows what its class is, and I can get that from an instance method called getClass, and that will return an object of type class with a capital C, and the class has a method called actually get name and but get simple name is just that what that will do for an instrument that will return the string instrument. Okay. So, but this is going to illustrate the polymorphism here because that one code, that same code is going to be implemented by executed by each of these guys. So you notice it's not defined in any of them, but it will execute this and correctly report which one it is. So let's, okay, so let's first, what did I have? I had a violin, and here's how we say extends instrument, right? And I get a red squiggly. What is it complaining about? The constructor. And again, now just to remember, when you get this error and you look at it and it says constructor instrument in class instrument cannot be applied to given types, required family found no arguments. You say, what the heck is going on? Because I didn't define a constructor. Well, Java put a constructor in. The constructor it put in was a 0 argument. And then after it put the constructor in, it said, oh, I see your constructor doesn't call super or this. So I'll put in a call to super with no arguments. But the superclass constructor requires a family. Okay. So how do we fix that? In this particular case, it wants one of these family things, and a violin is from the strings family. So I call super with a string, only I'm getting a red squiggly again, but it says it cannot find the symbol. So with these enums, I have a choice. I can either give the fully qualified name or I can give the unqualified name. And again, NetBeans kind of helps by allowing me to have this import here. Okay, now all red squigglies are gone. So now this is the other way that you can refer to enums is with the fully qualified name. That's what this is. So I'll leave that in just to kind of do that. Now notice that one of the things that it's complaining about, it says overridable method and constructor. Now, there are good reasons to kind of complain about that. And so one of the solutions is to change in this case, the setter method to a final method. So that says that I can't override this setter method, which is actually fine. Okay, so I'm showing you the two different ways of referring to an enum. One is, this is the unqualified name, and this is the fully qualified name. This is the actual name of the thing. This is the short name. And then And again, this is not something that you typically want to do. This is just for illustrative purposes. So this says when I invoke play, then this play will be, when I invoke play on a violin, it will just say, okay, I'm a violin and I'm playing this note. So let's, what's one of the other ones is I had a trumpet. Again, I need to call super, and this is a brass. And I fix the imports. And there we are with the brass. And then I'm going to set my tuning note to be a B flat. In this case, that's the right one. And just to be ornery, notice that, remember I was saying that the name of the argument doesn't matter. So for the violin, I called it note. For the trumpet, I'm just going to call it N. Okay, and the reason why, remember I said that it didn't really matter what you call these things. Notice that this overrides the instrument play method, even though the name of the argument in play is note, and the name of the argument in trumpet is just N. So that, and there's no red squiggly, so the compiler is not complaining. So that shows you that the name of the argument is not really part of the specification. That name can be arbitrary, completely arbitrary. And again, notice that this overrides this play, even though the name of the argument is different. What's important is the type. The type of the argument is exactly the same, and that's the important thing. Let's do one more. So you're kind of hopefully getting the idea here. And brass, and then again, just to be different, I'm going to do it the opposite way. Here, the tuning note for a French horn is an F. Come on. Okay, so again, how you refer to this, again, this is the fully qualified name, this is the unqualified name. It doesn't matter how you refer to it, as long as if I'm referring to it in an unqualified sense, I may have to import some stuff. If I'm using the unqualified one, I need to import. If I'm using the fully qualified one, I don't need to import anything. And just to underscore the fact that the name of the variable in the argument is not the important thing. It's only the type that's the important thing. Okay. So I think there was one I left out, but it doesn't matter. Well, I have enough to do the example. So let's, again, I always like to kind of put this in a separate Okay, instead of having a different one, I'll just put it in the in my where is it? My regular run here. So let's say test ism. Okay, so I'm going to test the polymorphism by let's make 4 of them. Okay, now again, this may sometimes be confusing, but whenever you see a cannot find symbol, there are 2 reasons for that. One is that you've fat fingered it, or I fat finger things all the time, or it simply needs to be imported. And in fact, if you click on this little light bulb to the right, it gives you some options. And if it says add import for, in this case, CS2173 music instrument, then that means that I haven't fat fingered it. I've just, it just needs to be imported. Okay, so let's do a trumpet. Oh, and again, it doesn't know what trumpet is. Now, just to show you that import, remember at one point I said import doesn't import anything? Instead of importing, you can always use the fully qualified name. So this is the fully qualified name of French horn. Notice I don't need the import. So import is very poorly named because it doesn't import anything. All import does is it allows you to use the unqualified name instead of the fully qualified name, and it just saves typing. I'm going to leave it like this. I'm going to give you 2 violins because I like violins. Okay. Now, I'm going to use, since I'm going to iterate over the whole thing, I'm going to use the for each thing. Now let's just print it out and see what's going on with that. Okay, so now we would expect, based upon what we've seen before, to have something sort of nice. We don't see anything nice, but now you should be able to understand what it is going on in several ways. First of all, and when we look at this, what we see is we see the fully qualified name followed by the @ sign, just followed by sort of random characters. Okay, so you should first of all recognize this as the fully qualified name. And what is the fully qualified name? Again, it's the package dot the simple name. Okay, second, you should also understand why it's printing this and not something a little prettier. So what the virtual machine is doing is first of all, when it prints an object, it invokes the toString. When you print an object like this, it invokes the toString. So let's look at, say, trumpet. So it tries to print trumpet and says, all right, I need a toString. Trumpet, where's your toString? Not here. Well, what's your superclass? Instrument. All right, let's check there. Instrument, what's your toString? Don't have one. What's your superclass? Object. See, now this notice that this is, we don't have to write this because it's always true. if we don't have anything else, but we can navigate to object. In an object, here's the toString. And in fact, we can see that, notice that I kind of used this before, get class, get name, there's the @ sign, and then basically it takes this thing called a hash code and it turns it into a hex string. Again, that's not terribly interesting yet. All right, so again, fully qualified name, @ and then this is this gobbledygoo. But how the virtual machine finds that is it go first for trumpet, it goes looking in trumpet, then it can't find it, it goes to the superclass instrument, can't find it there, finally lands in object, and it executes it's there. As I mentioned previously, because the compiler is so strict about this, it is guaranteed that any method will be found. The compiler guarantees that if I invoke a method, it will be found. Now that doesn't mean that there won't be an error, but that at least does mean that there's a fighting chance for it. Okay, so instead of that, let's now let's play. What I want to illustrate, which is a little different than what the book was doing. Okay, so let's tune. Everybody's going to tune. Now notice that the trumpet is tuning to its, the violin to its, the French horn to its, and then the second violin to its as well. So what code is being executed here? So here in the waning minutes, I'm gonna use the debugger, and we'll talk more about the debugger in future things. It's a very useful thing. I can add what's called a breakpoint here by clicking on the line number to the left. And what that will do is now if I execute by right-clicking and saying debug file, it will run to that breakpoint. And now it also gives me what variables are going on. It gives me something called a call stack, which is the set of calls. Now I'm invoking a method, and then here I use this little, the stuff up here at the top, and I can either step over or I can step into. So I'm gonna choose step into. And when I step into it, notice where it takes me. It takes me to the instrument method called tune. And the instrument method tune says get class, get simple name, tuning to blah, blah, blah. Now what I can do is if I step over, it'll just move to the next line. And if I step over again, it kind of takes me out here. But notice that it was actually the trumpet that was doing that. So let's do that again. This is the next one. And if I look at the variables, okay, first of all, let's look at this. See, this is in fact the violin. And if we open it up, we can see that it is inherited. Here's its family, the string, and here's its tuning note, the A440. And when that gets executed, again, the violin keeps going there. Now we can run to the next breakpoint like this, and we can keep running, and then eventually it's going to be finished. Okay, so the polymorphism here that I'm illustrating is the fact that the tune method in the superclass instrument was being executed by the instances of trumpet, violin, and French horn. And it was correctly telling you which one it was. So even though the method is actually in the superclass, because it was in the object of the type of the subclass, then it was correctly identifying it. So again, the same code was being executed on 3 different types, violin, trumpet, and French horn, the same code. And I didn't have to say, oh, if you're a violin, do this, if you're a French horn, do that, etc. It did it automatically. That's the polymorphism. Okay. We have 30 seconds for questions.
Sir,
Okay,
will
so
you be
all this is
uploading that?
clear? Am I beating a dead horse? Is this something that's too, am I going too slow?
Sir, will you be uploading that so we can use it to assist us in doing this next set of homework?
Yes, I will.
Thank you.